Hey everyone, and welcome back. I am the part-time economist, and in today's video, I am going to show you an easy way to make data-driven decisions. Now, I know with a lot of statistics videos, they get very complicated. We're talking about p-values and regression coefficients, and all of those things are really important for making the most accurate prediction. But sometimes what we're looking for is a rule of thumb, something that if we just knew one or two of the most important characteristics of our data, it could still give us a very meaningful prediction that's also easy to understand. So in today's video, I'm going to show you how to do exactly that. We are going to be working with the OneR algorithm and a decision tree algorithm using the R programming language. So with that being said, let's go ahead, let's jump in, and let's start learning. Alrighty, so the first thing that we're going to need to do is install some packages. Now, for this video, I'm obviously assuming that you've already got RStudio installed on your computer. We're going to need a couple additional packages. So those are going to be the Tidyverse, the OneR package, and the Earth package. Now, I will mention I am going to put all of this code on GitHub, so you can copy it, you can paste it, you can follow along, or you can follow along with the video. So we're going to install all of those packages, and then once we install them, we do need to pull them into our library using the library command. Okay, so we have all of those in the workspace. Now, the data set that we are working with today is the Titanic data set. This is a list of all the passengers on the Titanic, whether they survived, how old they were, what their gender was, if they had siblings or children or parents on board, right? A really interesting data set to look at. So what we're going to be doing is we're going to say, look, if we have this data set, how do we predict whether a passenger survives or didn't survive? Now, we are working with the Titanic data, but you could think of a lot of other real-world use cases where predicting yes or no is important. What's the most important determinant of whether the stock market goes up or down? If I see a wild frog, what's the one thing I need to know to determine whether or not it is poisonous, right? So there's a lot of real-world applications. We are working with the Titanic data set, and the first thing that I want to do is just get a look at the data itself. So we can see here we have the class of the passenger, their gender, their age, a lot of different variables, right? Now, one thing I'm going to do, and this is background information, do not get bogged down with it. I'm just going to convert the dependent variable to a factor. Again, do not worry about it. And then I'm going to do this so that we have some unknown data for evaluation purposes. So that you don't need to worry about. What we're going to do is let's just quickly look at the ratios here. So if we knew nothing else, we can look here and we can see that 619 passengers did not survive, 427 did survive. So if we knew nothing else about the passengers and someone said, hey, I want you to predict whether or not this person survived or not, we simply go with the average, right? And that is not surviving. So that is a zero rule, a rule zero prediction, because we don't know anything about the observation. We're just predicting the average, right? What if we could narrow it down to the one most important characteristic? So if someone said, hey, I'm going to let you know one piece of information about this passenger, what piece of information would we ask for? Well, that is where we're going to start looking at the data, but I want you to think about that. So let's visualize just really quickly. I'm going to show you here. We have obviously the gender of the passengers, and we have their age. Now, this doesn't tell us a whole lot, right? What I'm going to do now is I'm going to add in color, and we're going to color these dots by whether or not the person survived. And you're going to notice something really interesting. So the green dots are people that survived, and you can see there's a lot of green dots down there in the female category, and they are pretty well spread out. You'll also notice that there are not a lot of green dots in the male category. Unfortunately, a lot of males did not survive, but you will notice that the green dots that are in the male category are kind of pushed towards the end of that age distribution. So if you were a younger male, you had a somewhat better chance of surviving than if you were middle-aged. And again, if we look at the female category here, a lot of those green dots are kind of pushed towards the upper end of the distribution. So you should already be thinking, hey, there maybe is some variables here that might be interesting for me to know. Well, which is the most important? We do that using the one rule prediction. And the first thing we do, we create a variable. You can name this whatever you want. I'm calling it one rule. After that, we are going to use the ONER command, right? So one rule is what it stands for. The first thing we pass in is our Y variable. This is the variable that we're trying to find out. So in our example, it is, did the person survive? Yes or no. If you were doing poisonous mushrooms, it would be like poisonous, right? It's the column name from your data set of your dependent variable. Okay. Then we put the tilde and the period. All that means is it says, look, use all of the data that we have, find the most important predictor. And then, of course, we pass in the name of the data set, which is E-Titanic. So let's go ahead, run that. And when we take a look at this, it says that the one most important thing, if we knew nothing else about a passenger, we would want to know if they were male or female. Just knowing that one piece of information, we can predict with about 78% accuracy whether or not this person survived, which is really useful, right? Especially when we're thinking about the real world, right? If I'm going on a hike through the woods and I see a frog and I'm thinking, should I pet this frog, right? You can't expect me to know 15 different classifications. You want me to have a quick, easy to remember rule of thumb. Wow, that frog is bright red. It probably has some poison. Maybe it doesn't, but I'm better off not touching it because it gives me a good level of accuracy, right? So just with that one rule, we have some pretty good accuracy. And let me show you how to actually predict with that. So if we wanted to turn that rule into a prediction, right? So let's suppose now I said, hey, here are 10 unknown frogs, predict whether or not they're poisonous. All we would have to do is use the predict command. We pass in the one rule that we created up here, and then the unknown data set. It makes the predictions for us. And again, it's pretty simple, exactly what we expected. Anyone that is a male, it says they didn't survive. Anyone that's a female predicts that they did survive. And again, that is not bad, but we can do better. And especially if we are in a context where something is important to be accurate, we definitely want to aim for more than 78% accuracy. And we can do that using a decision tree. What a decision tree does is it kind of builds on the one rule that we were talking about. Instead of just looking at the most important characteristic, it says, okay, what are the next important characteristics? Basically, I like to call it a flow chart, right? So if this characteristic is true, then move on to the next one, right? And it gives us a lot more information. So what we're going to do for that, we do need to install two more packages, the rpart and rpart.plot packages. And then once you get both of those installed, pull them into your library. We create a variable. Again, this can be whatever you want to name it. We use the rpart command. And then again, this is the exact same as we did with the one rule. We are passing in the Y variable, the dependent variable. For us, it is survived. We pass in the data set. Let's go ahead and run that. It creates a decision tree. And when we look at that decision tree, it gives us nothing meaningful, right? If I'm looking at that, I'm going to be, what do all these numbers mean, right? Don't worry, there's an easy way to visualize this. What we use is the rpart.plot command. We pass in that decision tree that we created. You can leave this blank. If you wanted to, you could just do that. I'm going to show you a way that makes it easier to understand. Put type equals 3. You don't have to, but it makes it easier to understand. When we do that, it breaks everything down for us. So it says, look, we have all of our passengers, right? I want you to make a decision. Are they male or are they female, right? If they're male, what we're going to do, we go to the side that says male. Okay. Are they greater than age 9.5? Well, sorry, if you are a male and you are over the age of 9.5, we are going to predict that you do not survive. If you are a male and you are less than 9.5, then I have to ask you another question. Do you have any siblings or parents on board the ship. If you've got 3 or more siblings or parents on board the ship, sorry, you're not going to survive. If you are a male, if you are less than 9.5 years old, and you have fewer than 3 parents and siblings on board, we predict that you are going to survive, right? So I like this because it's really easy to understand. You just follow the directions, right? So if I had a passenger and someone said, hey, you have a second class female passenger. Well, I go down the decision tree, I go to where it says female, I go to where it says second class, boom. That is my prediction, right? It's easy to understand. It's easy to interpret. You don't need a statistics background to just follow the flow chart, right? So that can be very helpful. So that's really how you work with the decision trees. One thing I will show you just really quickly here. Sometimes when you are creating these, it will give you lots and lots of levels, right? So if we had, instead of these 4 or 5 variables, maybe we had 100 characteristics of the passengers. We don't want to create a super long decision tree. There's a way we can limit that. And the way we do that is using the max depth command, and we just type the number of levels that we want it to create. So if we run that again, it's only going to create 2 levels, right? Again, you're good to use the defaults, but if you wanted to shorten it, that's how you could do it. Last thing I want to show you before we wrap up, let's suppose that we made our decision tree and now we want to make some predictions, right? So someone comes to us and they say, look, I have this list of frogs. Here's what color they are. Here's how much they weigh. Here's all these characteristics about them. I want you to make a prediction. Are they poisonous or not? In our example, here's some passengers. I know their gender. I know their age. Tell me whether or not they survived. All we do for that, super simple. We use the same predict command. We pass in the name of the decision tree, and then we pass in the unknown data. What it does is it gives us, now this is really cool. 0, it predicts that that person did not survive. 1, it predicts that they did survive, but it also gives us an associated probability. So this one, we feel pretty confident predicting they did not survive. Here, with this one, we're predicting they didn't survive, but we're less confident. So I like that it not only gives us a prediction, but it gives us kind of the probability associated with that. So just to close out the video, I wanted to remind you that decision trees and the one rule algorithm are a great way of making decisions based off your data that can be explained to a non-technical audience, and that can be really useful if you're working in an environment where you want to make data-driven decisions, but the people applying and carrying out those decisions need something that is simple and easy to follow. So as always, I do appreciate you watching the video. I hope you found it useful, and I will see you next time.